Hello, is it audible now? Hello, okay. So, very good evening to all. So, today I am taking the Maxwell equations as per your GATE syllabus. So, actually, there are four Maxwell equations, that is, as per the Gauss law. Next one is Gauss law as per the Gauss law in terms of magnetic field, Faraday's laws of electromagnetic induction, then Ampere's law. These are the four Maxwell equations used in differential forms and integral forms. Okay, and some problems based on these Maxwell equations. So the first Maxwell equations is the following. The statement of Maxwell equation is electrostatic field equation will be developed in integral forms and differential forms. Actually, there are two types of Maxwell equations described in terms of integrals and in terms of differential forms. Okay? In differential forms, it's like a static. Again, that is time domain and static fields. Again, the Maxwell equations are defined based on the free space medium or without free space mediums. That is depends upon the mediums. Okay. The first Maxwell equation is integral of d into d of a is equals to integral of rho into b dv. Okay. So integral of d into d of a is the surface integrals. That is two integrals, double integrals. Whereas in volume integrals, that is the triple integrals, cube integrals. And in differential form, divergent of d is equals to rho. Okay. This equation can be derived based on the Gauss law. So what is Gauss law? So the Maxwell first equation is based on Gauss law of electrostatic published in 1832, where in Gauss law established the relationship between Gauss law is electrostatic field published in 1832, wherein Gauss established this relationship between the static electric charges and their accompanying static fields. Okay? So the Gauss law is defined. It is the relation between the static electric charge Q and their static fields, that is E values. The above integral equation states that the electric flux through a closed surface area is equals to the total charge enclosed. See, integral equation. So what this integral? This equation indicates that the electric flux through a closed surface is equals to the total charge enclosed. Total charge is nothing but that is the Q values. Now we'll see how we can defining this one. Okay, the differential form of the equation states that now we can see for differential equation, that is divergence of this one DAV d is equals to rho. This DAV is nothing but that is the divergent, not for the division. Okay, that divergence is represented as a dot product of electric field density, that is del dot D. Okay, the differential form of equation states that the divergence or outward flow of electric flux from a point is equals to the volume charge density at that point. Okay, so the divergence of the or outward flow of electric flux from a point is equals to the volume charge density. This rho is nothing but the volume charge density. Now, so that is the Maxwell first equation. So integral of d into d of s is equals to integral of rho into d of v, or delta d is equals to rho. That equation is defined based on the Gauss law. Now we'll see what is Gauss law. The Gauss electrostatic law states that the lines of electric flux phi e emanates from a positive charge q and terminates if they terminate on a negative charge. The space within which the charge exerts their influence is called electrostatic field. Okay, so the Gauss law, electrostatic law states that the electric flux phi e from the positive charge q and terminate if they terminate in the negative charge. The space within which charge exerts their influence. So where the charges is terminated in the negative charges, that space between the positive charge and negative charges, that influence is nothing but the electrostatic fields. Now see this diagram. The positive charges is represented as a plus q, and the negative charges is far away from the positive charge if the distance is some r value, then the field is exerted from the positive charge to the negative charges, and in the positive charge the field is outward. The negative charges is the field is in inward. Okay, so the figure represents the charges and a three-dimensional fields. The field is visualized as being made up of lines of flux. These lines are nothing but the flux. For an isolated charge, the lines of flux do not terminate and are considered to extend to infinity. Okay, so these lines of flux do not terminate and are considered to extend up to infinity. Now, based on this Q value, to obtain the equation relating to this electric charge Q and the flux pi, assume that the charge is centered in the sphere. Now, this charges is placed in the sphere, okay, spherical coordinating system. Already, there are different types of coordinating system, that is Cartesian coordinate, spherical coordinate, and cylindrical coordinate. Cartesian coordinate, also called as a rectangular coordinate, representing the terms is x, y, z, whereas cylindrical coordinate representing the parameters rho, phi, and z values. Whereas in spherical coordinate, the terminals are represented with r, theta, and phi. R is the radius from the point when the current element is placed in the spherical coordinate with a distant point is P, the distance point of P with a distance of R with an angle theta, and phi is the azimuthal angle. So the distance from the point P from the origin is from 0 to infinite with an angle of theta is lies between 0 to pi, and azimuthal angle is from 0 to 2 pi. So assume that the charge is concentrated in the sphere of the radius r. That's why here the sphere of the radius is r. Then the electric flux density is equals to the electric flux emanating from the charge q divided by the area of the sphere. So D is equals to q divided by area of the sphere. So the area of the sphere is equals to what? 4 pi r square. So therefore D is equals to the electric flux density. D is equals to Q divided by 4 pi r square. So D is equals to pi of E, that is flux density, electric flux divided by area. Area is equals to 4 pi r square, and phi is equals to electric flux. Now, this unit of electric flux density is coulombs per square meter because the charges is in terms of coulombs. So 1 coulomb is equals to 1.606 into 10 to the power of minus 19 plus 19, and the area is in terms of square meters. So therefore the D value is coulombs per square meter, where the area is a perpendicular to the lines of flux. Here, 1 coulomb is equals to the magnitude of charge, that is 6.25 in the 10 to the power of 18 electrons. Actually, the charge of an electron is equals to 1.6 into 10 to the power of minus 19 coulombs. Okay, so the charge enclosed in the sphere is then equals to the electric flux density on its surface times the area enclosing the charge. Then Q is equals to, here D is equals to, from the above equation, D is equals to Q divided by 4 pi r square. Therefore, Q is equals to D into 4 pi r square. Okay. So D is the electric flux density and 4 pi r square is the area of the sphere. Next, so the lines of flux contributing. So the lines of flux contributing to the flux. మదన్
సార్ క్లాస్ జాయిన్ అవ్వలేదంట
నేను జరుగుతుంది క్లాసు.
జాయిన్ కాలేదంట
ఏమో నేను చెప్తాను, 4:30కే స్టార్ట్ చేసేసిన.
అవునా
ఈసీనే కదా దీంట్లో.
అంతే ఉండదులే
అదే ఓకే.
సరే
సర్లే, రికార్డింగ్లో ఉంది.
ఓకే
The lines of flux contributing to the flux density are those that leaves the sphere perpendicular to the surface of the sphere. This leads to the integral statement of this portion of Gauss law. So Q is equals to, now here previous cases is the Q is equals to చెప్పు మదన్.
లింక్ సార్ నేను ఇచ్చాను కదా లింక్ EO0 సంథింగ్.
నాకు ఇక్కడ ZVX టీజో ఈసీ దాంట్లో నేను షేర్ అయింది.
కాదు సార్ నేను ఇచ్చాను చూడు మీకు వాట్సాప్ లో పెట్టిన ఆ లింక్తోనే కదా.
నేను డైరెక్ట్ గూగుల్ క్లాస్ రూమ్ లో ఉంది కదా ఈసీ దాంట్లో.
కాదు సార్
ఇప్పుడు నువ్వు ప్రేరణ మెయిల్ ఐడి ఓపెన్ అవుతుంది, ఈసీ క్లాస్ ఉంది కదా
దాంట్లోకి వెళ్ళినారా? స్టూడెంట్స్ ఎంతమంది ఉన్నారు?
ఎవరు లేదు దీంట్లో.
అదే సార్ నేను చెప్పేది పిల్లలు ఆ లింక్ తో జాయిన్ అవుతారు. EO0 ఉంది చూడండి, ఆ లింక్ తో జాయిన్ అవుతారు. మీరు మళ్ళీ కొత్త మీటింగ్ అవసరం లే.
కొత్త లింక్ కాదు బా, అక్కడ ఈసీదే.
ఈసీ క్లాస్ రూమ్ తో పనే లేదు సార్. ఈసీ క్లాస్ రూమ్ తో పని లేదు. నేను మీకు వాట్సాప్ లో ఒక లింక్ పంపించాను కదా.
అవును,
ఆ లింక్ తో జాయిన్ అవ్వాలి మీరు.
ఓహో అట్లాంటావా?
అది నేను చెప్పేది EO0XSUB అని చూడండి.
సరే ఒక్క నిమిషం ఉండి ఇది లాగౌట్ చేస్తా.
దాంతో అవ్వాలి సార్.
సరే దాన్ని అందరూ స్టాప్ చేయమని, నాకు రికార్డింగ్ రాదు.
అందరూ ఎక్సిట్ అయిపోయినారు.
సరే ఒక్క నిమిషం ఉండి అయితే.